of the same as what we did on Tuesday, and the reason being, Tuesday we did multiplying fractions. So today we're doing almost the same thing. What do you think we're doing? Dividing fractions. And the reason why I say it's almost the same thing is because dividing fractions is pretty much multiplying fractions just with one change, right? Okay, so this section is 6.3, and we're going to be dividing fractions today. Okay, and let's write down a quick division rule for fractions. Now, the reason why I said it's almost the same thing is because it kind of is. If I look at the fraction, just kind of a generic form, a over b divided by c over d, we usually don't divide with fractions. What we do instead is we turn it into a multiplication problem because dividing is the same thing as multiplying by the reciprocal. So this is the same thing as a over b times d over c. So we're going to take all of our division problems today and turn them into multiplication problems, and then the rest is the exact same as what we just got done doing on Tuesday. Okay? So the directions today, just say divide, and always should be kind of implied that we want to write our answers in simplest form, right? Don't have to ask me, just assume. Always in simplest form. Okay, number 1, let's try 2p over q divided by 8p over 5q. Okay, if you ever are given fractions and you're supposed to divide them, we need to change it to a multiplication problem first. So that first fraction, it stays the exact same. That 2p over q does not change. Okay, that division sign we can change to a multiplication sign only if we flip that second fraction. So 5q over 8p. Okay, you're always going to flip the fraction that comes right after the division symbol, okay? And then, like I said, this is what we did on Tuesday, right? What can I reduce? Okay, there's some p's that can be divided out, and the 2 can divide out, and the 8 turns into a 4. Anything else? The q's divide out, so the only thing in the numerator I'm left with is a 5. And the only thing in the denominator I'm left with is a 4. All right, questions? More of the same? Yep. A lot of fun. I know you had a lot of fun doing your homework before, so just a lot more fun. Okay, number 2. Let's try a squared b over 4 divided by 2ab squared. All right, so the first thing we got to take care of that division sign. I cannot divide fractions, so the first fraction stays the same, a squared b over 4. I'm going to change the division to multiplication, so I'm supposed to flip that second fraction, but it's not even a fraction. But it's over 1, right? Or we can think about this way. What's the reciprocal of 2ab squared? 1 over 2ab squared, right? Okay, you can either write it over 1 and then flip the fraction, or think of it as a reciprocal. Okay, now what can I reduce here? Okay, there's one of these a's cancels out. What else? A b cancels out. Anything else? Nope. So in the numerator, I'm left with an a. And in the denominator, I'm left with a 4, a 2, and a b. I need to multiply them all together, so what's in my denominator? 8b. A over 8b. Any questions so far? Okay, we'll keep trucking along here. Number 3. 2 divided by 4y over 5, and we're going to square that second fraction. Okay, if we kind of think back to what we did on Tuesday, what do you think I need to do first? Exponents. I've got to get rid of that exponent first. To get rid of that exponent, I need to take everything inside that set of parentheses to the second power. So once again, we're going to leave this as 2 divided by, but I have to square the 4 and I get 16. And then I have y squared, and 5 squared for the denominator gives me 25. Now I can go back through, change that division sign to a multiplication sign. So the 2 stays the same, and then I'm going to multiply by 25 over 16y squared. If you want to write that 2 over the 1 so you can actually see the two fractions, that would be okay. Any reducing? Okay, the 2 and the 16. I can divide out of 2. 16 turns into an 8. Anything else? Nope. So what's your answer? Very good. 25 over 8y squared. Okay, so pretty much most of you guys had all day, right? Yeah. Just wait. It gets better. Number 4. 3 plus 3y over 6 divided by 1 plus y over 9. Why do I say it gets better? What are we going to do? Abby? Factor! Best news you guys have heard all day, right? Yes? Okay. How would you factor 3 plus 3y? We can factor out a 3. I'm left with 1 plus y. I can't factor the 6. It just stays a 6. And if we want to go ahead and change that division sign to a multiplication, we can, which means I have to flip that second fraction. Now, what can I divide out here? Okay, the 1 plus y cancels that. Anything else? Okay, so you could do one of two things here, right? You can divide out the 3 from the 6, or could you divide out a 3 from the 6 and the 9? Do you think it matters? It doesn't matter. So it doesn't matter. I'm going to go ahead and divide out the 3 here, and then the 6 becomes a 2. But once again, it wouldn't matter. If you want to divide out a 3 from the 6 and the 9, you would get the exact same thing. Multiplying across, we have a 9 in the numerator and a 2 in the denominator. Okay, number 5 just gets better. Y squared minus 16 over 4y divided by y minus 4 over 20. Okay. Greatest thing, right? This is so fun, guys. Okay, I need to factor that numerator. How would you factor y squared minus 16? Tara?
Y plus 4, y minus 4.
Very good. It's a difference of squares. I have y plus 4, y minus 4. I cannot factor that 4y, and I also can't factor anything in that second fraction, so I'm going to go ahead, change the division to a multiplication, flip that second fraction, and then let's reduce. What divides out here? Eric.
The 4 and 20.
Okay, I can divide out a 4. The 20 turns into a 5. What else? Tara?
Y minus 4.
The y minus 4. Anything else? Nope, that's it. So, whenever you're ready to multiply in your numerator, anything that's in parentheses kind of needs to stay in parentheses. So I'm going to have 5 times the quantity y plus 4, and then what in the denominator? Just a y. Any questions so far? Doing okay? Not too bad? Pretty much the same thing as what we did on Tuesday? Okay? All right, I just have 3 more. Really, they only get harder because you just have to do a little bit more factoring. Okay? Do you have a question?
Is it okay if we factor the 5 out?
Factored a 5 out from where?
No, if you distribute the 5.
Oh, that would be okay. So distribute the 5 and you have 5y plus 20. You don't have to, but you could. That means the same thing. Yes?
But then wouldn't you have to factor out the y? Or is it just 10?
Even if I distribute this, it'd be 5y plus 20, right, over y, which those y's can't cancel out because it's not multiplication, right? So, no, good questions, good questions. Does that help? I probably wouldn't distribute it because on the off chance that you don't distribute it correctly, then you got it wrong and you probably did it correctly, but you just didn't distribute it. So I probably wouldn't. Kind of for the same reason that if you don't have to change it to a mixed number, then don't. Because if you make a mistake changing it to a mixed number, it's going to be wrong when you actually did it correctly, okay? Yes?
You said it got harder, but it became funner.
Oh, you're right. Not harder, funner, right? My 4th hour told me that funner is not a word, and I said in math class, It is a word, right? Well, how else would you describe this?
More fun.
Less fun.
I would say funner. Okay, number 6.
Definitely where I'm at.
Number 6 says y squared minus 1 over y squared minus 4 divided by, you guys ready for this? Y squared plus y minus 2 over y squared minus y minus 2. Lots and lots of factoring here. We're so pumped and excited. Let's go. How would you factor y squared minus 1? Y plus 1, y minus 1. What about the y squared minus 4? Pretty much the same way, right? Y plus 2, y minus 2. Now for me, since I do have to factor that entire second fraction, I'm not going to change that to a multiplication just yet. I'm going to leave it as a division. That way I don't get confused when I'm factoring and flipping things. So let's look at that numerator. I don't want to know what it would be, but how would you factor y squared plus y minus 2? Yes.
Why?
I don't want to know what it would factor to. I want to know how. What did you do?
You would multiply y squared and negative 2.
Okay. Factors of a negative 2 that adds 2, right? What you're getting at? That add to a positive 1. Factors of C that add to B. So factors of a negative 2 that add to 1. And then you came up with what factors? A negative 1 and a 2. So y minus 1, y plus 2. How would you factor? I don't want to know what the answer is, but what method would you use to factor the denominator? That's the same one, right? Except this time I'm looking for factors of a negative 2 that add to a negative 1. So what would you have to change? Just flip the sign. So this time I have a y plus 1 and a y minus 2. Okay? Now that everything's factored, we can go ahead. We're going to keep the first fraction the same. But whenever I change that division sign to a multiplication symbol, the numerator becomes the denominator becomes the numerator. And then, this is the fun part, right? Crossing things out. What cancels out here? We have a y minus 1 that cancels out. What else? A y minus 2. Anything else? Anything else cancel out? Nope, that's it. So I have y plus 1 times y plus 1 over y plus 2 times y plus 2. Is there another way you could write that, Abby?
Y plus 1 squared over y plus 2 squared.
Very good. Y plus 1 quantity squared over y plus 2 quantity squared. I do not care which way you write it. It means the exact same thing. I would accept either one. Yes?
Why can't there's 2 cancel out?
Which two?
Like y plus 1.
The ones in the numerator? Because they're both in the numerator, right? One would have to be in the denominator. Good questions, good questions. Anything else? And move on. Okay, 2 more. We'll do one together and I'll have you try the last one all on your own. Number 7. X over y squared times 2 over x squared divided by x over y. Using your prior math knowledge, what do I have to do? First, I've got to get rid of that exponent, those parentheses, right? So that means I have to take x squared and I have to take y squared. Since that first symbol is a multiplication symbol, that fraction stays the same. It's going to stay a 2 over x squared. But if I want to change this division sign to a multiplication symbol, what else do I have to do? Flip the fraction that comes right after the division sign so that x over y becomes a y over x. Now it's all multiplication. What can cancel out here? Oh, look, and x squareds cancel out. Well, that's nice. What else? One of these y's will cancel out. Anything else? Nope, that's it. So I have a 2 in the numerator and an xy in the denominator. Okay, last one. I want you guys to try this one on your own. I'm going to put it on the board, and then I'm going to have somebody explain how you would solve it, and then I'm going to have you guys go through and simplify it. Okay, so we're going to have x squared minus 4 over x squared minus x minus 6 divided by x minus 2 over 2x divided by 4x squared plus 2x over x squared minus 9 divided, no, I'm just kidding, that's it. Okay.
I'm gonna cry.
Okay, so before you start factoring and flipping and simplifying, could somebody explain to me kind of step by step, just generic steps, what you would do to simplify this one? Right, brave enough to do it. Tara.
First, you want to factor out each
Good.
fraction,
Good. Factor everything.
and then you flip the two after division signs,
Awesome.
and then cancel out and simplify
Exactly.
whatever's left.
Exactly right. Go through, factor everything, and then any fraction that comes after a division sign, you're going to have to flip that one. So I want you guys to take a second, see if you can get that simplified.